So the purpose of this video is to have some lectures on some topics of pre-calculus. And I want to start by talking about set theory. And this will be a very basic introduction to set theory because we don't need that much. Um, we will only need a few things, some definitions and examples for the pre-calculus part. So we can start by asking ourselves, what is a set? The question that is very fundamental in this topic is, what is a set? And the answer is that set is just a collection of objects. What does that mean? Well, let's say I have some people named John, Emily, and let's say Arafat, and then maybe we have some of their friends known as Beetle. I don't know what kind of a name is Beetle, but yeah, let's assume for the sake of the argument that Beetle is a name. And yeah, so this all study in the I was saying, if they all study in the same school, so and they're a group of friends, okay, so we can call this collection of people a set. Now, if this example is too weird for you, what you can do is that you can take another example. You can take some animals, let's say cats, dogs, deers, tigers, and stuff. This collection of animals can also be called a set. So anytime you have some objects and you have a collection of them, you can call that a set. Now, how does that help us doing mathematics? Well, we'll see. So for us, in this basic level, a set will mean a collection of numbers for now. So we'll call it a collection of numbers. So let's define a set called A. This is our set, and we can define it like this. Let's say 1, 2, 3, 4, -5, 6, and so on. So this is something that we'll call a set of numbers. Why it is a set of numbers? Well, because this is a collection of numbers. It's like we're gluing them together with some curly braces separated by commas. So this is the way to write a set, and this is something we call a set of numbers. We can also have fractions, decimals, and whatever inside of a set. So if you would like to construct another set, let's call this set B, and let's say it has elements like 11 by 2, 0 0.05, -1, 0, then -1 by 5, and so on. And these dot dots mean that there are more elements. And this is another set, okay? And throughout this discussion, we will only deal, we will and other stuffs. Since this is pre-calculus, I'm only restricting the discussion to real numbers. Maybe in future we will talk about set of complex numbers and so on. Okay, now that's out of the way. Now, if I ask you to identify a set of integers, so let's say this is a question to you. Identify a set of integers. And let's say I'm giving you three options, not two because two would be too easy. So option A contains a set like A, and option B will contain a set like, let's say, I'm also calling it a, and option C is this. And this is pretty easy to identify because we want to have a set, that means a collection of objects, but this time only we are taking into considerations the integer numbers, right? And the only set that we have integers all the way around is option number C. So this will be a set of integers. Similarly, you can call a set of positive numbers or positive integers denoted with Z plus as 1, 2, 3, 4, 5. Oh, yes, it also has 0, and so on. You can have a set of negative integers denoted by this bold Z minus sign as -1, -2, -3, and so on. Then numbers denoted by n is 1, 2, 3, dot, 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 and so on. These are different kind of sets, some special sets and stuff like that, but we don't worry about them too much over here. What we do want to know about some facts of set theory is that there is a set called the universal set. So this is a hypothetical set that is something like the universe itself, whatever you want to talk about. This set contains everything, okay? So this is a hypothetical set that contains everything. So usually people when they do set operations, they need to define some universal set, and from there they construct different sets. We'll keep this at the back of our head for now, and we will define, since we already defined what is a set, we want to define a new thing called a subset. What is a subset? A subset is just a smaller portion of the set itself. Let's say you have a set, let's call that U, of 1, 2, 3, 4, 5, 6. And let's say A is some set such that it has 2, 3. And in this case, we're gonna call is a subset of U. Why? Because A contains all the elements from U, and what we see more is that we don't have 4, 5, 6 over here. So this is a smaller set than U. This is true. At the same time, all the elements of set A is coming from the set U, so we call a subset of U, and mathematically we can write it like this. A is a subset of U. This is the subset symbol. In fact, in some cases, these are called proper subsets, but we won't go into that deep over here. Okay? And if B is a set that is something like this, in this case, B is not a subset of U. Why? Because U doesn't contain any zero, however, B contains a zero. So we cannot construct B from the elements that we have in U. We need another extra element that is not inside of U. So B is not a subset of U. Okay? Now, we talked about subsets. Now let's move on very quickly to the next discussion, which is union and intersection of sets. So just like numbers, when you have numbers, you can add them, subtract them. In set, you can do um, operations like that. And one of them is called a union of two sets, and the other one is called intersection of two sets. And obviously, if you can do it for two, you can do it for more as well. So for now, let's focus on two sets only. Let's say A is a set like this, 1, 2, 3, and B is another set that is -2, -3. If I want to glue them together, I will call that a union. What does that mean? It means I'm constructing a new set out of these two sets that will contain all the elements of the first set and all the elements of the second set. So to form a union, I will write it like this: A, some capital U, B. And this will look something like this. And the end result is just, you just write all the elements that you have from both sets. So this is like sticking two sets together. This is called a union. Let's say another example. Um, let's call another set C, which has 2, 5, 7. If I want to do A union C, I'll write 1, 2, 3, union 2, 5, 7. And now you see you have 2 in both of the sets. So this is a general rule. If you have an element that is common in both the first and the second, in their union, you don't write it twice because that won't make any sense because they're the same thing. So we write it only once, and this union is just 1, 2, 3, 5, 7. Now, if you ask, okay, I know how to glue two sets together, what about three? So let's say we do A union C first, and then we do the union with B. What does this mean? It means first you do A union C, you have a new set, right? And with that set, you glue together the set number B. So we already have this result over here, A union C, 1, 2, 3, 5, 7, and union B, B was -2, -3. So this result is just 1, 2, 3, 5, 7, -2, -3. And it really doesn't matter how you write them, in which order you write them. So you could even write -2, 1, 2, 3, -3, 5, 7, and so on. It really doesn't matter the way you write them. I mean the order. In fact, you can show that this A union C union B will be the same as A union B union C, or A union C union B, and so on. You can just go around and play around with these things. Okay? So this is how you can, define union of a set. And now comes the topic called intersection. All of this may seem a little bit abstract, but in the next video we're going to talk about Venn diagrams. When we talk about Venn diagrams, things are going to be much more clear because it will help you to visualize that the mathematical operations we are doing here so far. So by intersection, we mean if you have a set A, let's say you have some set, and then you have another set B, and let's say we have another set, this C. By intersection, we mean if you have two sets, and when you try to intersect them together, you see if there are any common elements that are presented in both of the sets. And if there are, you pick them out, and that will be your new set, and that is called the intersection of a set. What do I mean by this? Well, the intersection symbol is given by this symbol over here. So this is the intersection symbol. And let's say I want to find the common elements of A and B, or between A and B. So I write A 1, 2, 3, 4, 5. I use the symbol again, and I can see that I have element 2, element 3, and the element 5 between both sets. These are the most common things between both sets. All the other elements are different, right? So my result would be a new set, which is just 2, 3, 5, like this. Pretty easy. Now, what about this? What about if I want to find any common elements between A and C? And if you just look at A and C, you will see there are no common elements at all. So first you want to write no common elements at all. And this is the result that is denoted with this symbol, which is called the null set. That means there is nothing in common between these two sets. Okay? So in this case, A intersection C, you can use this curly braces, or you can just forget about the curly braces when you write a null set. So this is valid both ways. Like you can write it like this, you can write it like this. Since there are no elements between these two sets are common, no common elements in between them, you can call the result or the intersection as a null set. There is one last operation that I want to talk about, some brief introduction. That is some sort of a subtraction. I like to call it um, subtraction. It's like subtraction, but it's really not. So let's say if you have a set A as 1, 2, 3, 4, 5, 6, and then you have a set B, let's say 1, 11, 12, and let's say you have another set C called 2, 3, 4. Now you can define an operation like this that looks like this, and what this instructs you to do is that you can take set A and use this sort of subtraction symbol and then write set B. And what this symbol instructs you to do is that if you see any common elements in between these two sets, you just forget about them. In the new result, you just don't write them at all. Some sort of a annihilation is happening over here. Even this 11, 12, you forget about them. Whatever set or whatever elements stands right to this symbol just gets destroyed. However, if there is a common element in between these sets, they also get destroyed too. So that would mean the result is just 2, 3, 4, 5, 6. Okay. Similarly, if you do A subtract C, you will have, because A is 1, 2, 3, 4, 5, 6, and C is 2, 3, 4, you can just write A subtract C as 1, 3. Oops, sorry, not 3. 4 will get cancelled out. So now we can write A subtract 3, A subtract 1, 5, and 6. Now, if you have another set, let's say set D, which is 2 and 5, sorry, not 2 and 5, let's say 20 and 50, and you want to do A subtract D, you see that 20, 50, they're not over there, right? And this symbol instructs us to just forget about this elements in this set and write whatever is left. So nothing really gets cancelled from A, so you can just write the answer is this. So this is some basic operations of set theory, and I do realize this is a little bit abstract if someone is seeing them for the first time. However, when we talk about Venn diagrams in the next video, I'm pretty sure all of you will get some intuition about these operations. And if you have enjoyed, or if you have any thoughts and comments, you can let me know down in the comment box. And I do appreciate your support. So if you think this content was any help to you, you can consider subscribing or sharing this with others. Thank you.